Okay, thank you for your patience. I know your notes probably say Unit 9, but it's actually Unit 7. So we're going to be talking about ratios and proportions, which are basically the same thing. Ratios, I'll give you some vocabulary, but just so you know, a ratio is a fraction and a proportion are equal fractions. So I'll give you some more vocabulary and whatnot, but really that's what I want you to remember. So a ratio is a comparison of two numbers. Whoa, I'm gonna have to fix that. That's not gonna work. Try that. Comparison of two. Oh man, what's going on? Comparison of two numbers by division. Okay, and so just remember fraction. A ratio is a fraction. Now you can compare height and width. You can compare balls to strikes. You can compare any two numbers, cups of flour to cups of sugar. So you can compare any two things. If you're comparing those two things and we set it up as a fraction, it's considered a ratio. A proportion are just two equal ratios. Two equal ratios. So that kind of makes sense. If you have 1/2 equals 4/8, that's a proportion. Okay, and so then I have this idea of, actually, let me draw you and show you what it might look like. So let's suppose I had a ratio A over B equaled C over D. So when we're talking about ratios, it's oftentimes we like to look at this, and I want you to think something should pop through your head is when we got proportions, we should be thinking cross multiply. That a cross, if I take the top times the bottom, it will equal the other cross, the bottom times the top. Now in math, we give things names. So I'm going to talk about extremes. It's just which two letters am I looking at? And when I talk about means, it's the other two letters that I'm looking at. So you have these notes to refer to, but if you ever see the word extremes, I'm referring to the A and the B. The top and the bottom, this is considered my extremes. And then the other two, the C and the D, are considered my, and now I gotta get over here. The C and the B, I'm sorry, the B and the C are considered my means. And what I would just tell you is the extremes are the top, A and D, and the means are the B and the C. Just know that in a true proportions, the extreme equals the means. If you the product of the extremes equals the product of the means. So if I cross multiply, they're equal. I'm just going to draw a little arrow over to, if it will let me. Yeah, it's so weird. I don't know why this is so hard to do. I don't know why it does this. Okay, so, and then the means, and then the cross products. What I would like you to know about the cross products is the cross products are equal. And so let's do a little bit of work here. Let's make sure that we can solve some of these. So let me give you an example. 5/7, 5/7, is that equal 45 over 63. So the question I'm asking is, are these proportions? Are these proportions? And the way we do is we cross multiply. So let's take the extremes. Let's take this 5 times 63. Literally grab a calculator. 5 times 60 is 300. 5 times 3 is 15. So is 315 equal, and 7 times 45, well, 7 times 40 is 280 plus 30. Oh, it is 315. So does 315 equal 315? The answer is yes. So we know then that the extremes, the product of the extremes, 5 times 63 equals 7 times 45. Now, I can answer the question, are they proportional? That's really great. But I can also do questions of what would a number be if they were proportional? For instance, example number 2. What if I had this question? 3/8 equals, I don't know, over 56. Well, what we do know is that if it is a true proportion, then my extremes, the product of my extremes, will equal the product of my means. So I can know that 3 times 56, that's 180. 180 will equal 8 times x. And now just so we know, is 56, I think I did that correctly. I got to check now. 56 times 3. Oh, it's not. I'm totally wrong. 3 times 6 is 18. And 3 times 5 is 15. 168. Whoa, I was totally off here. So this is not 180. This is actually 168. So we can see where I got that by cross multiplying this 3 times 56, and that equals. So this is an algebra problem. So when we solve algebra problems, we have to do the opposite. So in this case, we're going to divide by 8. And it leaves me with x equals 21. So I get a value of x equals 21. And that's good. So I can say, yeah. So I was able to figure out the unknown by doing my cross products, by multiplying the product of the extremes, and having that equal to the products of the means. All right, let's just practice with one more. It's okay to even have more than one unknown, and maybe not more than one unknown, but you'll see when I write up this example number 3. Example number 3, what happens if I have something that looks like this? What if I have 2y over 9? What if that equals 8 over 4y? Well, it's okay. It looks weird, but what isn't weird is that it is a proportion. And when we have a proportion, we use the cross product. So we say the extremes, multiply these two things together, 2y times 4y, and that will equal the means, the products of the means, 8 times 9. Well, 2y times 4y, multiply the numbers, that's the easy part. 2 times 4 is 8, and y times y is y squared. And 8 times 9 is 72. And now this is still an algebra problem. So the other one, it was a little simpler because I could just divide and get my variable. This time I'm going to divide, and I don't get my variable. I get y squared instead of just y. But 72 divided by 8 gives me 9. And so then I need to get rid of this squared. And so I think, what is the opposite of squaring? Well, the opposite of squaring is square root. So I can actually take the square root of y and say then y equals, what is the square root of 9? And if you punch this onto your calculator, it's going to give you the answer of 3. And the only thing I'm going to make you be aware of is that it actually could be both positive or negative. I'll accept the answer is 3. Don't worry about this. But the answers can actually be positive or negative 3. Square roots, truly a square root, can be the positive value or the negative value. So just keep that in mind that it can be either or. Great. And so I think the last thing we have now is the big question, the big reveal, which is why. Why are we doing this? What's the big deal here? Why do we want to know this? Well, proportions are dealt in many areas of real life. I'm just going to give you a few areas in the real life where proportions show up. Whenever you scale something up or down, and when I say scale, I'm talking about in construction, I'm talking about in baking, I'm talking about in drawing. Anytime you scale something either up or down, we can use this idea of proportions. So that's really good. So, like I said, scaling up and down, that applies to cooking. If you get a cooking degree, go through culinary arts, and you want to do cooking, a lot of times cooks don't cook for poor people. They cook for a large group. And if you're going to cook for a large group, then you will need to know what to order in order to have enough food to make the dishes that you want. So you'll need to know about this idea of scaling up. Planning, if you were going to do like any party planning. Now, I know that this sounds crazy, but if you're going to do any party planning, if you figure out like what kind of goes into a bag and you need to make sure that everybody at the party gets one, you'll need to scale those orderings up or down. I just want to tell you, it makes a lot of math easier. It makes a lot of different parts of math easier by using this idea of cross products. Sometimes we can do cross products for some pretty difficult things, and we will get into it when we talk about laws of sines and laws of cosines. We will be using this idea of proportions to solve and find out some very difficult things in mathematics with very basic, the very basics of proportions. So those are just a few areas that you will be using this idea of cross products. Anyway, thanks very much for your time. You did a great job today, and I will see you soon.